Welcome back, guys. Today we have an interesting question, and this came in one of the recent mock tests. So let's discuss how to solve it. An ancient vault is secured by a 4 cross 4 grid of stone panels. The grid consists of 4 rows, R1 to R4, and 4 columns, column A to column D. So first we'll just draw. Yeah. So since there are 4 rows and 4 columns, I think we might need more space, or it's fine. It is fine, I think. Yeah. So R1 to R4, R1, R2, R3, and R4 horizontally, and A, B, C, and D. That's what the question says. In the grid, every integer from 1 to 6 through 16 is placed exactly once. Every row, column, and both main diagonals sum to 34. This is an important point. Every row, every column, both main diagonals, that means this and this, both add up to 34. The 4 corners also sum to 34. Okay, so we have 16 numbers. I have it ready, so never mind, it's here. So I just made a table of all the 16 numbers, so it's easy for us to cross it out whenever we are done with it. And we have been given the information as follows. R4D is the only number that is both a perfect square and a cube. Let's see how many numbers are squares. So 16 is a square, 4 is a square, no squares here, 9 is a square. Neither of these three are cubes. So let's remove all of these. Any cubes in the house? 8 is a cube. We missed 1 in the square series. 1 is a square of itself, yes. 1 is also a cube of itself, true. 8 is a cube, but not a square. So there's only one number which is a square as well as a cube. So at R4D, we have put 1. Done. R1A is the square of R4A. Great. So R1A is the square of R4A. So let R4 be X, therefore R1 becomes X square. Now there's an interesting approach, right? We know that the 4 corners sum to 34. So what are the number square pairs do we have? So we have 1, 2. We have 1, 1, but it can only be used once. So we do not have 1, 1. We have 2, 4. We have 3, 9, and we have 4, 16. Now, this x could be either 2, 3, 4, and this x square could be respectively 4, 9, and 16. Now let's see. The third corner we have 1. So 1, 1, and 1. What number do we need at the fourth corner to make the sum 34 in all the three cases, right? Let's see. 2 plus 4 is 6 plus 1, 7. We need 27 here. Won't be able to get it out of this set. So remove this. 3 plus 9 is 12 plus 1, 13. How much do we need? We need 14. Or do we need 24? No, 12, 13. 1 is 4. 21. Again, out of the set. 14. Sorry, 4 plus 16. That is 20. 20 plus 1, 21. We need 13 more. This is the only possible case of a number square pair where we can add the 4 corners and make it 34. So let's put R1D as 13, and the x square would be 4 square, that is 16, and R4A, that is the x, would be 4 and 16. Now this is done. Row 1 contains the lowest and the highest prime numbers. So what is the lowest prime number? It is 2, right? Everybody knows it. What is the highest prime number in this set, if you can see? Correct. It is 13. 16 is not a prime number, 15 is not, 14 is not, 13 is the highest prime number, and 2 is the lowest prime number. Now we see we already have 13 from the second rule. Now in either of these two places we have 2. So I'll just write it in black for placement as a placeholder. Now let's go to the next point. Row 2 begins and ends with, oh, you know what? I missed a point here. I think every row also sums to 34. Now, we know that we have 1, 2 here. We have 13 and 16 here. So let's add 13, 16, and 2. What does it give us? It gives us 31, right? 9 to 11, 11, 3. So 31 may, what do we need to add to make it 34? Everybody knows we need to add 3. Now, it's so easy. It's going to be 2 and 3 in the first row. We might not know exactly where it will be, but we know that 2 and 3 are going to be in the first row. Now, let's move on. Let me just clean this up. So, next point is row 1 contains, this is done for us, highest and lowest. Row 2 begins and ends with the Fibonacci numbers. Okay, Fibonacci numbers are nothing. We are given 0 and 1 always. And the third number is always the sum of the previous two, 0 and 1. This is by default. So 1 plus 0 is 1. Then again 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 5 is 13. 13 plus 8 is 21. And so on. As you can see, 21 is the number which is out of range of this given set. And we cannot use 0. It is not in the set. 1 is already been used. We don't need 1. 13 is already used. We can't use 13. 2 and 3, we know they are in the first row, so it cannot be in the second row. Now, the only two numbers remaining are 5 and 8. Now, we know 5 and 8 might be either here or here. Let's just keep crossing the numbers off which we have placed correctly. So 1, 4, 13, and 16 are crossed off. Uh, so now we know the places of 5 and 8 temporarily. Let's move on to the next rule. It might help in solving the question. Modulus of R3A minus R2A. So R3A is this, let it be A, and R2A, let it, okay, B. So basically, mod of A minus B is equals to R4A, that is R4A is 4. Yeah, it's right here. So we know it's either 5 or 8. So what numbers can we subtract from 5 to make the result as 4? We can have 5 minus 9 or 9 minus 5. Sorry, it's A minus B, right? So it should be 9 minus 5 and not 5 minus 9. We can have 9 minus 5. That will give us 4. Or we can have 1 minus 5, that will give us minus 4, but the mod would always give us 4. But we have already used 1 here, so this is a case we can reject. For 8, is there any number? Yes, there is. Of course, there is. And that number is 12. So now 12 minus 8 gives us 4. So now we know the numbers here could either be 12 or 9. Is there any other number? 4 is also there. 4 minus 8 gives minus 4. Again, it's a mod, so we put mod here, that gives us 4. But we have already used 4, so it cannot be repeated. Now we know A is either 12 or 9. Let's move on to the next rule. R4B equals R1B. So R4B, this part, is equals to R1B into R3B. Both of this we do not know. I think another point which I have skipped, I don't know if it's going to help us or not. We know the columns also add up to 34, right? So 16 and 4 gives 20 already. This plus this gives 20. So this must, the sum of these two must give 14 to us. So can you see any combination which is giving 14? 8 and 12 do not give. 5 and 9, yes, they do give. So easily we can say the numbers here are 5 and 9. Let me write this in green. Because the column sum is always equals to 34. It's given right here. Let's move on. Now we know this. So yeah, we know this place also, that is R2D. We know now this is 8 because 5 is already placed in the front and it ends with the Fibonacci number. Okay, so do we know this place as well? 13 plus 8 is 21, 21 plus 1 is 22. Now we need 12 here. Great. We had 12 here and it got placed right here. We have completed a huge part of our problem now itself. Oh, R4B is equals to R1B into R3B. So R4B is equals to R1B, that is either 2 or 3 into R3B, which we do not know. So let's park it for now. Let's not rush into it. R3D is a multiple of R4A. R3D is a multiple of R4A that we already know and we have already used. Now R4C is a multiple of 5. R4C, this is a multiple of 5. Okay, multiple of 5. I'll just write 5 in the bracket. There are only two numbers which are multiple of 5, 10 and 15. Suppose we take 10 here. So 10 plus 4 is 14, plus 1 is 15. How much do we need? So to make it easier for you to read, I'll just park it here. It can be either 10 or 15. So 10 plus 4 is 14, plus 1 15. We need 34 as the sum for the entire row. So 15, we need 19 here. Is it possible? It's not possible. So 10 is instantly knocked out. 15 plus 1 16 plus 4 20. We need 14 here. We can get 14 here. So let's just mark it 14. Now, there was something said about these two and the fourth R4B. It was said that R4B is equals to R1B into R3B. R1B is either 2 or 3. We don't care. But 14 can never have odd factors, can it? It has, or it can have, but it doesn't have. It has 2 and 7. But we have a 3 as an option. So we can instantly reject 3 from the R1B column. That means this place is 2. That makes this column R1C as 3. Okay, let's put it as green. We get this as 2, 3. So this automatically becomes 7 because the product of these two is R4. Now it's so easy now. We know that the sum of diagonals, or let it be, we know these four sum up to 34, right? And we initially saw that 13 plus 4 already 17. So these two must be equal to 17. 7 is here. This must be equal to 10. There are only two numbers left. That is 11 and 6, if I'm not wrong. So let me put this in green again. This becomes 15. So where do you think 11 and 6 would go? We'll just add and check, wouldn't we? If we put 6 here, so 2, 8, 8s and 15, 15 and 14, that becomes 29. So 6 wouldn't go here. Now we got our answer. 11 would go here and 6 would go here. Now we have our table. Let's clear the clutter up if that's gonna mess with, uh, yeah. Now we'll get to the questions in just 2 seconds. Yes. What is the value in R2C? What can we say about R2C? Let's see. R2 is here, C is here. It is 10. Easy. What is the difference between the sum of the numbers in the four central cells? and that of the numbers in four cells in column B. Okay, four central cells add up to 34. So 34 minus all the numbers here, that is 34. Do we even need to solve this table to answer this question? If this question comes in your exam and you skip it, it's just because you're unlucky. Because reading the question, we know the sum of the numbers in the four central cells. It was given in the question itself. I'll show it once again. Four corners also sum to 34. If the four corners are summing to 34, the four central cells will also sum to 34. Why? Because 16 plus 1, 17, 13 plus 4, 17. It will sum to 34. So, yes, the answer would be 0, 34 minus 34. The third question is, which of the following statements is definitely true? Definitely true. Let's see. Column C contains exactly three prime numbers. Column C contains no. There's only one prime number, that is 3. So this is wrong. The sum of R1A, R1B, R2A, and R2B. So row 1 AB and row 2 AB, 16 to 18 and 11, 5, 16 is 34. 18 and 16, is it 34? Yes, it is 34. So it is correct. Let's still check the other two options. R2D into R4D is greater than 10. R2D and R4D. R2D is 8. R4D is 1. 8 into 1 is not greater than 10. This is wrong. Row 3 contains entirely odd numbers. 9, 7, 6, 12. 6 and 12 are not odd numbers, so this is wrong. We got our correct option B. What is the sum of the numbers placed in the cells adjacent to, that is sharing a side with, cell containing the number 1? 1 is at R4D position. So adjacent cells wouldn't include 6 because it's not sharing a side. The only sides that are being shared are 12 and 15. When we add it up, we get 27. So that would be our answer. This was a good question. And when if it comes a similar question like this comes into your exam, you should not panic with the looking at the length of the description, and try solving it on your own once, get a hang of it. I think it'll be an easy scorer for everyone for their exams. Thank you.